Special triangles. What are special triangles? In the world of mathematical modeling, there are two triangles that contain three measures of angles that are used much more frequently than others. These are called special triangles. The first is the 30, 60, 90 degrees, or in radians, pi over 6, pi over 3, pi over 2. And the second is the 45, 45, 90. Let's take a closer look at the first type of special triangle. You need to make sure that you know this. I would keep it on a separate piece of paper to help you as you're doing these questions. At the bottom is the 60 degree. At the top is the 30 degree. The side opposite the 30 degree is measure of 1. The side adjacent to the 30 degree is measure square root 3. And the side that represents the hypotenuse has the measure of 2. This is exactly the same if we're expressing our angles in radian measure. 60 degrees is equal to pi over 3. 30 degrees is the same as pi over 6. Same side measures. The second special triangle is the 45, 45, 90. Here is how it would look. It is an isosceles triangle as the two angles have the same measure. The two sides will therefore also have the same measure. The measure is 1. The hypotenuse is length square root 2. If we look at the same triangle in radians, 45 degrees is pi over 4, exactly the same triangle. Now, if you look more closely at these special triangles, you are given the lengths for the opposite, adjacent, and hypotenuse sides to be used in calculations. This is extremely useful when solving trigonometric problems. Here again, the 30, 60, 90, 45, 45, 90, and the same in radians, depending on what unit of measure you are using. How can you use the special triangles? When performing calculations, you want your answers to be as accurate as possible. To do that, you need to make sure you are using exact values. If you use these special triangles, you can get exact values for sine, cos, and tan. To do that, let's start by filling in the table on the next slide, showing the exact values of sine, cos, and tan for the given angle measure. And here is the table. So we have the degrees, we have the radians, and using opposite over hypotenuse for sine, adjacent over hypotenuse for cos, and opposite over adjacent for tan, we have these preset measures for the trig ratios. Now, here is a sample of the type of problem you could solve using trigonometry and special triangles. A ladder that is 2.5 meters long is placed against a vertical wall so that the top of the ladder makes an angle of 30 degrees with the wall. Draw a diagram to represent the situation. How far up the wall is the top of the ladder? Give an exact answer. Now, the clue that we need to use special triangles is given when the word exact is included. So our hint of the day, exact means use the values from the special triangles. If we were given the word approximate, we would use decimal values and round off. Now, let's take a look at the solution. The first thing we wanted to do is to draw the diagram. The wall meeting the ground, with the ladder positioning from the ground to the top of the wall. We know the ladder is 2.5 centimeters. We know that it makes a 30-degree angle, and we know the wall meets the ground at a 90-degree angle. Now, let's work out the solution. Let h represent the height in meters to be the height of the wall from the top of the ladder to the ground. The length h is adjacent to the reference angle of 30 degrees. The length of the hypotenuse is 2.5 meters. So, adjacent over hypotenuse would be cos. So the cos of 30 degrees is the length of the wall divided by the length of the hypotenuse, which is h divided by 2.5. Now, continuing on, the cos of 30 degrees is equal to h divided by 2.5. But we also know from the table the exact value of cos of 30 degrees is square root 3 over 2. We can now make the statement that h over 2.5 is equal to square root 3 over 2. Now, continuing on, h over 2.5 is square root 3 over 2. Just to recap, we're going to solve for h by, you've got it, cross multiplying. H equals 2.5 times the square root of 3 divided by 2. So h is 1.25, which we got by taking 2.5 and dividing by 2 times square root 3. And now we know that 1.25 can be written as the fraction 5 over 4. So we know then we can replace 1.25 by 5 over 4, and we will get the exact value, 5 times square root 3 divided by 4. So the conclusion, the top of the ladder is 5 square root 3 divided by 4 meter up the wall in exact value form. You will learn more about the special triangles in the next video. Stay tuned.